Hi, and welcome to this section of the Calculus 1 Derivative Help Tutor. In this section we're going to learn how to take derivatives using what we call the product rule of differentiation. So in the last sections we learned how to take basic derivatives, and especially things that are added together were very easily done by just taking the derivative of each part and just adding up the results. We learned how to deal with the fact that when we have a function with a constant in front of it, we just take the constant out and then take the derivative of the result. So we're going to expand our horizons a little bit, our skill set, and start talking about what happens when we have two functions, two bona fide functions of x multiplied together times one another. And the answer might surprise you. It's not quite as easy as it sounds, but once you get a little bit of practice, it's very, very simple. Okay, so what am I talking about here? I'm saying that if we have two functions, we'll call them f and g, then if I'm going to multiply them together, it might look like f multiplied by g. Now these are not variables, these are actual functions. F could be sine of x. I haven't told you how to take derivative of sine yet, but we'll get there. This could be, f could be x squared. G could be, 1 over x cubed. They could be anything at all, any functions of x. When you multiply them together and then take the derivative of the product of them, we have to use the product rule of differentiation, which is the following. And I'm going to say it about 10 times because I want you to memorize it. This is what you do. You take the first function, f of x, and multiply it times the derivative of the second function. So first times the derivative of the second plus the second function times the derivative of the first function, f prime of x. Again, I'm going to say that about 10 different times. So I'll put a little dot here just so you know these are multiplied. It's implied. It's important that you really remember this because you'll be using the product rule of derivatives all throughout Calculus 1, Calculus 2, Calculus, everywhere, because it's fundamental. Think about how many functions you might have. X squared times natural log of x. Those are two functions multiplied together. X cubed times parentheses x squared plus 5. Two things multiplied together. Anytime you have two functions of x multiplied together, you take the first function, multiplied by the derivative of the second function, plus the second function times the derivative of the first function. Your book may have it written in a slightly different order. This is how I think about it, so I'm writing it this way. First times the derivative of the second, plus the second times the derivative of the first. So it's really not that bad once you get into working some problems. But let's look at a real example. Let's say we have some function, composite function that has two guys, 2x minus 3x plus 5. Now, first of all, I want to say, in my general definition, this up here at the top, this is just the sort of the general rule, right? I used f and g to represent the two different functions. But, in most of the time when you're doing your problems, they're going to say f of x for your function. So you got to not be quite so literal. This f of x is not the same as this. It's just saying this function consists of two different functions multiplied together. Here in my definition, I was calling this f and this g. I could have labeled them anything I want. Usually in your book, it'll be labeled like this, so that's why I labeled it that way. But basically, fundamentally, it's saying two functions multiplied together. First function times derivative of the second, plus the second function times the derivative of the first. So if this is the first function of x, and this is the second function of x, you proceed in exactly the way we've outlined. So we say the derivative of this multiplication is going to be the first function, 2x minus 3, times the derivative of the second function. So we write it like this to keep our work straight. X plus 5 derivative. Have not taken the derivative yet. So I'm going to do that in the next step. I don't want to get too far ahead of myself. First function times the derivative of the second, plus the second function times the derivative of the first function. Now, it's tempting in Calculus 1, once you learn these rules, to start taking the derivative like right away and start to for instance, when I wrote this down, I could have taken the derivative of this and wrote it down. I can take the derivative of this and write it down too. But when you start skipping too many steps like that, especially in the beginning, you'll probably make an error. So my advice is, at least if you're just learning this the first time today, then do yourself a favor and write this step down and then simplify it in the next step. As you get more experience, you can handle and can bite off a little bit more each time. But notice we've done exactly what the rule said. So we'll just keep going. We have 2x minus 3 Now we have to take the derivative of this guy, with respect to x, of course, because it's only a function of x. What is the derivative of this? We learned how to do that in the last section. The derivative of x, this is just x to the first power, is simply going to be 1. And that's all it's going to be, because you have 1 in the exponent, it's going to come down, times x to the 1 minus 1 is 0. So it's going to be 1x to the 0 power. So it's going to be 1, because x to the 0 is 1. So you're going to get a 1 here. The derivative of this 5 is just 0, so it disappears. So this 1 is everything here after we take the derivative of it, okay? Plus this guy, x plus 5, times the derivative of this. So we need to take the derivative. The derivative of 2x is going to be 2. The derivative of this negative 3 is going to be 0, so that's going to be it. Why is this derivative 2? It's because this is x to the first power. So when I take the derivative, the 1 is going to come multiplied by the 2, giving me this, times x to the 0 power, because I subtract 1 off the exponent. So this is going to disappear. The x is going to disappear. This 3, derivative of any constant, is 0. Make sure you understand everything that we've done so far. It's very, very important. Okay, let's keep going. Now we need to just do some multiplication. So we'll have 2x minus 3, doing this multiplication, plus here 2x plus 10, doing this multiplication. And then finally you can simplify the answer by combining terms. 2x and 2x is 4x. This plus this is going to give me 7. 4x plus 7, and that is the final answer. So make sure you take things one step at a time. You have two functions basically that are multiplied together. So you take the first one times the derivative of the second one, plus the second one times the derivative of the first one. And you're going to do that over and over and over again in this section because all of these problems are going to be having functions that basically are multiplied together. All right, so we take the derivative of this and get this, take the derivative of this and get this, do some simplification, and boom, that's the answer. A couple things I want to say before we go on. First one is, notice that the derivative of this is just the 1 and the derivative of this is just the 2. So if I actually skip this step, which, you know, once you get better at calculus you can do, if I basically eliminate this and take the derivative in my head and write it down and take this in my head and write it down, and so my second line is this, it doesn't really show what you were doing. I mean, you have a 1 here and you have a 2 here. So if you get the problem right, then great, yeah, you got the problem right. But eventually you will make a mistake. Eventually you will. And if you don't show any intermediate steps, then when you're taking a test and you don't show any of those steps, then the guy's not going to know if you knew what you were doing or not. But when I show it explicitly like this, I will know that the student knows to take the derivative of these guys. Maybe you make a mistake later, but I know that at least you know that. So my advice in the beginning is to show all of the work. It's never going to hurt you, and it's always going to help you. One final thing I'll say is we use the product rule here because that's what the section's about. We can multiply and do the product rule here as we've shown. But just to sort of as an aside, if you wanted to, you could do FOIL here and multiply, get 2x squared minus 3x plus 10x, and then you have minus 15. So you could get a polynomial out. And then once it's in polynomial form, we've actually taken derivatives of polynomials in the last section over and over again. You just take the derivative of each little part, right? If you were to do that and get the result, you're going to get this. You're going to get this answer. So don't feel like there's one right way, one wrong way. You can do whatever you want, but when you're learning how to do the product rule, we need to present some problems to show you how to use it properly. And even though you might say, well, I don't need this product rule, I can just do this all the time. Well, there's going to be cases. I mean, what if here in a few sections when I throw a sine at you or a tangent at you or a secant at you as the second function? Then you're not going to be able to use multiply and get polynomials. You're going to have to use the product rule. So my advice is, even if you might see a way to simplify it and change it into some other easier way to take a derivative, just make sure you know how to do this because it will become required for some of these problems coming up. All right, so the next problem. Let's go and do that now. So let's say we have g of x is equal to x minus 2x squared, and the whole thing is squared. And you might look at that and say, well, where's the product rule here? Where are the two functions here? He hasn't told me how to do this. But actually, you can rewrite this. And my advice is for you to rewrite this as the following. I think you can see where I'm probably going to go with this. 2x squared, x minus 2x squared. This is just what this is equal to here. So write it this way. Now you have two functions of x multiplied by one another. And you can use the product rule of differentiation. So we can say g prime of x is equal to first term times the derivative of the second. So we'll say x minus 2x squared times the derivative of the second, x minus 2x squared, derivative, plus the second guy times the derivative of the first, x minus 2x squared times the derivative of the first, x minus 2x squared. So in this case, derivative. In this case, it's pretty silly because every term is really the same thing, but still, this is how you would methodically take this derivative. So to continue on, we're going to leave this alone. We can't really do anything with it yet, 2x squared. What is the derivative of this term? The derivative of the first part, this is x to the first power. You're just going to get a 1. The 1's going to come out of the exponent times x to the 0 power. What are you going to get for this derivative? You'll have this negative 2 times 2 when the 2 comes down, so you have negative 4x. Subtract 1 off the exponent, you're going to get 1. So we'll just leave it as negative 4x. Okay? And then plus. Notice that these two terms, because of this problem, they're exactly the same. So I'm going to get the same thing here. I'm going to have x minus 2x squared times 1 minus 4x. Times 1 minus 4x. Now there's a million different ways you can proceed, but you know, I could do FOIL here, I could do FOIL here, I could simplify, but the fact of the matter is I've taken the derivative. Literally, this answer is the derivative. But since I see that these terms are duplicated, I'm just going to wrap my answer up and just put a 2 out here and say x minus 2x squared times 1 minus 4x. And I'm just going to call it a day. And that is the correct answer. You could really leave it like this, but you know, it's not totally simplified. I could expand this out and bust it all out and collect like terms. That's fine too. When you take derivatives, you're going to find a lot of times you're going to get down to an answer and then you have to simplify it. It's kind of like, you know, simplifying a fraction. You know that you need to do it. It's just that sometimes you're going to get down to a point where maybe you don't want to simplify anymore because it's really not that fruitful. It's not going to do anything different than what you already have. And it's sort of like style points anyway. So the most important thing is to make sure you're taking the derivatives right, because if you plot this function, it is the derivative and it will look exactly like this guy here because they're the same thing. And if you expand this guy out, then of course you're going to have the same thing again. All right, let's do another one. Let's say we have y is equal to 3x plus 1 times 2x squared minus 5x. So here we have a classic thing. We have function A and function B. They're multiplied together. Sure, I could distribute all this stuff out, collect terms, and then take the derivative, but why not just use the product rule? This is the first function, this is the second function. So instead of y prime, just to mix up the notation, I'm going to say that dy dx is the derivative. You can write it this way. You can write y prime if you like. So it's going to be the first term, 3x plus 1, times the derivative of the second term, 2x squared minus 5x. Take the derivative. That's reminding me I need to take that derivative. Plus the second function, 2x squared minus 5x, times the derivative of the first one, which is 3x plus 1. Okay? And I have to take the derivative of this guy. So first times the derivative of the second plus the second that times the derivative of the first. And that, honestly, is how I've remembered it for all these years. Sometimes you sing songs to yourself to remember these things. Sometimes you have a rhyme, whatever. I've just memorized it by saying it. First times the derivative of the second plus the second times the derivative of the first. Some calculus books write it in the reverse order, but it's exactly the same thing. So that's how I'm teaching you here. Now I need to take these derivatives. dy dx. This I'm just going to leave alone for now, 3x plus 1. Now how do I take the derivative of this guy? The derivative of 2x squared. 2 times 2 is 4, and then x to the first power, because I take my exponent and subtract 1. Now negative 5x, the derivative is going to be just simply negative 5, because I've got negative 5 times the 1 from this exponent, but then it becomes x to the 0 power, which disappears. So I'm left with this, plus, here I'm going to leave this alone, 2x squared minus 5x. And over here, the derivative of 3x is just going to be 3 the derivative of this 1 is just 0 because it's a constant. The reason this is just 3 is because you have 1 coming down to multiply, giving me this, times x to the 0 power, so it disappears. Okay? Now there's a million different ways you can go here. Technically you could circle your answer because it is correct. You could plot that, that is the derivative. But you know, we can just do some simplification here and just see how simple we can make it. So we'll do the whole 9 yards. So this guy, 3x times 4x is 12x squared. So let me wrap this in parentheses. The inside terms is going to be 4x. The outside terms is negative 15x. And the last terms is negative 5 plus. When I distribute this guy in, let's wrap it up in parentheses so I can keep them separated. 3 times 2 is 6, so 6x squared minus 15x. Okay, so since everything's really summed together, I can ignore the parentheses. There's no minus sign here, so I can pretty much pretend they're not here. And basically go and simplify the answer. So what I'm going to have is dy dx. Let's look at the x squared terms. I'm going to have 12x squared and 6x squared. If I add them together, I'm going to get 18x squared. Okay? So I've kind of, let me just get another color out. I've kind of taken care of this term and I've kind of taken care of this term. All right, now for the x's, I'm going to have here 4x minus 15x, which is negative 11x. So negative 11x, so negative 11, and the negative 15 is going to be negative 26. So I'll have negative 26x. This plus this plus this. So doing all of that, I've kind of taken care of these terms. So I've done everything. The only thing I really have left is negative 5. So the answer is 18x squared minus 26x minus 5, and that's the final answer. So it's significantly simpler than what I started with. So it's probably worth your while to do that there. Okay, but again, first times the derivative of the second plus the second times the derivative of the first. And as you start doing these problems, you will find that if you just know and understand these rules of taking derivatives, that they're bulletproof. There's really a lot of tediousness to it, but they're bulletproof. Once you know how to do it, you can always do it. When we get into some other topics later in Calculus 1, you know, integration and things, there's a real technique to knowing what to do. If you don't see it, then you're not going to get the answer. But with derivatives, it's not the case. If you see a derivative, you'll definitely be able to take the derivative of it in a bulletproof, step-by-step fashion. Okay, let's go ahead and see. What if I had f of y, so some function of some variable y squared plus 1 times 2y minus 7. Again, I have two functions that are multiplied together. So if I wanted to take df dy, or I could say f prime, I'm just using different notations to give you practice, it's going to be first times the derivative of the second times the derivative of the second guy plus the second guy, 2y minus 7, times the derivative of the first, y squared plus 1. Like this. First times the derivative of the second plus the second times the derivative of the first. So continuing on, whoops, df dy. Derivative of this function f with respect to y is going to equal y squared plus 1. Now how do we take the derivative of this? 2y minus 7. Well, the derivative of this is simply going to be 2, because the 1 from here is going to come down and multiply, but I'm going to have y to the 0 power. It's going to disappear. Derivative of this constant is 0. Plus 2y minus 7 times the derivative of this. Well, derivative of y squared is 2y. Derivative of 1 is always 0. So this 2 comes down in front, y to the first power. So I've taken my derivative. Technically, you could circle your answer. But, you know, it's better to simplify when you can. So multiply this, 2y squared plus 2. That's what I get from this. And then over here, plus, here I have 4y squared minus, from here, 14y, right? Minus 14y. So I've basically done everything. df dy, I'm going to have y squared combining with this, giving me 2 and 4, I should say, is 6y squared. Right? The negative 14y hangs around, can't combine it with anything, and the 2 hangs around, can't combine it with anything. So 6y squared minus 14y plus 2. And again, just using the product rule, in a methodical way. So what I'm going to do here, I could really stop the lesson here and say, hey, you know how to do it. But what I really want to do here is work a few more problems just to give you more practice and try to get a little more complicated each time. But I want you to know that these problems forthcoming, they're not really harder than what you know and what you've been doing. They're just more tedious. It's like, you know how to add fractions, 1/2 plus 1/2. You know how to do that. But if you add 5/36 plus 6 117ths, yeah, you know how to do it, find a common denominator and add the fractions. But the fractions are just more difficult to work with, so it's going to take more steps and a little more thinking to add those two fractions. Same thing with this. You know how to do it, but you have to practice it so that when you come up to a roadblock and you have to roll up your sleeves and simplify something, it won't freak you out so much. So keep that in mind. Next one is, and this is a good example of that, we'll have 1 plus 1 over x times 2 minus 1 over x. It's a great example of that because, yeah, we have function A and function B and they're multiplied together so we know what to do, but when we end up taking these derivatives we have 1 over x in there and it just looks ugly, not easy to work with. My advice is what I've always sort of told you to do. When you have anything like that, rewrite it. So I would rewrite this as 1 plus x to the negative 1 power. And would rewrite the second guy as 2 minus x to the negative 1 power. And that way, when you take your derivatives, you have a nice exponent, and it's very easy to deal with. When you look at these fractions, it just, it doesn't lend itself as well to it. So when we take the derivative, it's going to be the same thing. First times the derivative of the second, 2 minus x to the negative 1 prime, that's the derivative. First times the derivative of the second plus the second, negative 1, times the derivative of the first, prime, like this. First times the derivative of the second plus the second times the derivative of the first. Okay, so let's roll up our sleeves and take the derivative. 1 plus x to the negative 1. How do we take the derivative of this guy? Derivative of 2 is 0, so I don't have to write anything. Derivative of this, I've got a negative. This negative 1 is going to come down and multiply, giving me a positive 1. Positive 1. So I don't have to write that, but I'll just put a 1 here just to remind you. So this is 1 times 1 is 1, negative, negative, positive. And then I'm going to have x, and I'm going to subtract 1 off the exponent, so it's going to be 2. Very important you understand that. Negative 1 minus 1 gives me negative 2. Make sure you're doing that right. So multiply the front guys, take the exponent, subtract 1. Okay. So now you see why it's a little harder to look at, but it's so much easier than looking at this. Plus 2 minus x to the negative 1 times the derivative of this. Derivative of 1 is 0. Derivative of this is negative x to the negative 2. Negative 1 comes down, giving me this. Negative 1 minus 1 gives me negative 2. So again, like I've been saying, theoretically you could just stop there. This is the derivative, but you're not going to probably get full credit because you really have got a lot of stuff that you can simplify here. So take it one step at a time. Multiply this stuff in, right? That's my advice to you. Multiply this stuff in. There's a lot of different ways to do it, but let's just do it that way. So let's multiply and just see what we get. So what we'll have over here, I'll open up parentheses. This times this is just going to be x to the negative 2 because it's times 1. Plus, when I multiply these, I'm going to add the exponent. So I'm going to have x to the negative 3. Negative 1 plus 2 gives me negative 3. And then over here, I'm going to have this guy. So I'll have negative x to this guy multiplied then in. So I'll have negative 2x to the negative 2. And here, negative times negative is positive. So I'll have positive x, and I'll add these guys together, giving me negative 3. Okay? So it already looks a lot better. I have a lot of ugly negative exponents around, but I can simplify it a little bit more because I have an x to the negative 2 here and I have x to the negative 2 here, so I can add these guys together. So I have a 1 here and a negative 2 here is going to give me negative x to the negative 2. Okay? And then when I add these guys together, I'm going to have plus 2. X to the negative 3 because I have 1 in front of here and 1 in front of here, and that guy stays along for the ride. So you can totally circle this guy as the answer, but it looks a whole lot better without dealing with all those negative exponents if you write it like this. So take this guy, 2 on the top, make it a positive exponent in the bottom, plus Actually, it's going to be minus. So I put this out in front so I can put a minus here, and it'll be 1 over x squared. And that looks a whole lot better than any of these other intermediate steps. So 2 over x cubed minus 1 over x squared. The only reason I flipped the order was so, I could have done it like this, but then I'd have a negative sign out front. So I just flipped it so I could have the negative in the middle. It's just a style thing. It's not like you have to do it this way. But you see what I mean? It's totally the same method. First times the derivative of the second plus the second times the derivative of the first. But because the negative exponents, because they're all running around, it's, then you have fractions when you go to the final answer. Kind of like that fractional example I gave you a little earlier. It's all the same stuff, but because you've got a little bit more complicated expression, it's very easy to make a sign error. So take it one step at a time is my advice. Now what we're going to do is erase the board and work a few more that ratchet up the complexity just a tiny bit and show you how to handle it.